Hello, this is John from TC Math Academy, and in this particular video, we're going to be using the properties of logarithms to take this logarithmic expression and write it as a single logarithm. So if you think you can figure this out, go ahead and put your answer into the comment section. Also, if you need math help with the course you're taking, test prep or homeschooling, make sure to check out my math help program at tcmathacademy.com. You can find a link to it in the description below. And also, if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so I'm going to show you the answer right now. If you want to work on this for a little bit more, just pause the video. But literally, if you know what you're doing, this will take you all of about 15 seconds to do. Let's go ahead and take a look at the correct answer right now. So again, we're going to take this expression and write it as a single logarithm using the properties of logarithms. And this is the answer. All right, so this would be a very basic type of problem in terms of properties of logarithms. And when you're using logarithms, basically you need to know how to do two things. So this problem here is we took a big log expression and we kind of put it into a nice simpler form. In other words, we took something with pluses or minuses and powers and all kinds of numbers and stuff like this, and we simplified it effectively, kind of just in a very non-technical way, describing what we call condensing a log expression. So if you have this big old log expression and you want to write it as a single logarithm, we call that condensing. And then the reverse is true. So what we can do is take an expression like this and then kind of write it all out in a larger, more expanded log expression. Basically, this right here would be the answer. And that question would be expand this log expression, okay? But what we did here was to condense or write this as a single logarithm. So, all depends on how your textbook or teacher is teaching this to you, but those are some terms that you need to know that are relevant to this problem. But if you got this question right, let's go ahead and give you a nice little happy face, an A plus, a 100%, and a few stars, so you can tell your friends and family that you know how to condense a basic log expression using some properties of logarithms. I'm pretty sure they'll be very impressed with that knowledge. So let's go ahead and get into this right now. Okay, so I'm not going to go through all the properties of logarithms. There's not that many, but that's kind of, you really want to kind of go through a basic, review a full lesson, let's just say on this. So I don't want to do this a disservice by just quickly showing you 1, 2, 3. I do have additional videos on logarithms on my YouTube channel. And if you really need help with this stuff, check out my courses like Algebra 2, College Algebra, or Pre-Calculus. I teach logarithms completely and thoroughly. But basically, what we have to do is use the property of logarithms just step by step to simplify this logarithm into one expression. And basically, this is the entire solution right here. So let's go and talk about this right now. So the first thing you need to know is when you have a number like this, like a constant in front of a log expression, this 3 log x right here, you want to deal with numbers that are outside of a log expression. And there is a property of logarithms that this 3 really, okay, is the exponent to this x. In other words, if I had log x cubed, that is equal to 3 log x. There is a property for that. That's one of the properties of logarithms. Very, very critical property as well. We use this all the time, especially when you're solving exponential equations, okay? And you use logarithms. When you study logarithms, you study them in conjunction with exponential functions as they are inverses of one another. Okay, so hopefully you knew that. Okay, so that's what we want to do first. We want to go ahead and move any numbers up back into their exponent location. Now, if I had like a 7 right here, 7 log y, I would move that 7 up, and that would be like right here. Okay, like that exponent would be a 7 on this y. But of course, that's not the scenario. But just to kind of make sure you understand this. Now, if you're confused about this, well, you're likely, didn't really get enough instruction on the properties of logarithms or we don't understand the formulas. Okay, so again, just kind of follow through with some of the suggestions I gave you on this. But one thing you can't do is just be like, oh, I won't need to use this. You absolutely need to know the properties of logarithms if you're taking any one of these courses. Okay, so here we go. So we have 3 log x. We move that 3 up. So now we have log x cubed plus log y. So the next property that you need to understand is when you have addition of logarithms, when you see a plus sign between logarithms, what we're talking about is that, and by the way too, there's something important. These are both log base 10, common log. So in other words, these properties, well, let me just kind of tell you the final answer, then I'll make my point. Okay, I probably did that a little bit out of order. But anyways, as long as these logs are the same base, that's what I want to say, then when we're adding logs, this is multiplication. Okay, so in other words, log x cubed times y, this is all the common log or log base 10. In other words, this expression here, if I was expanding it, I can just separate these factors of this product this way. Okay. All right, so let me go and write this out. So I'm expanding this out. Sometimes it's easier to expand an expression before you condense it. Personally, I think that's the best way to learn this. But anyways, when you have 2 logs separated by a plus sign, these right here can form, these are factors of a product. You would simply write it like this. But the point I was trying to make before I kind of stumbled around a bit is that if these logs have different bases, in other words, let's say this is log base 7 and this was log base 9, then that would not apply. Remember the property of logarithms, the bases are the same. Okay, so again, if you're familiar with natural logarithms, if you had ln, let's go and do it this way, ln xy cubed, I can separate this out. We're kind of doing an expanding problem right here. This way, ln x plus ln y cubed. Write that a little bit better. Okay, so we have ln x plus ln y cubed, right? So I can separate these two factors in this product by an addition. So here, I can use that property of logarithms I just showed you to write our final answer this way, ln x plus, I can drop this 3 right down in front of that ln, that would be 3 ln y. So ln is the natural logarithm, that is log base e, and hopefully this is all stuff that you're familiar with. If you're studying logarithms and you're looking at this and you're like, just like, I don't have no idea what you're talking about. Well, that's a pretty good indication that you need to kind of brush up on all this stuff. Logarithms are awesome. I mean, they're so powerful. I think what confuses students about logarithms, it's brand new. They generally don't teach you about logarithms in like an Algebra 1 level course, certainly not in pre-algebra. So all of this, is going to be introduced to you in these courses like, again, Algebra 2, College Algebra, Pre-Calculus, etc., etc. Okay, so hopefully this little video helped you out. If that's the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.